In section 8.2, we're starting with trigonometry. Trigonometric ratios are used, actually in real life, for people that are in professions that deal with angles or ramps. In this example here, it says that contractors use trigonometric ratios to build ramps to meet legal requirements. So according to the ADA, the Americans with the Disabilities Act, the maximum slope allowed for a wheelchair ramp is a 12th, which is an angle of about 4 8/10 degrees. Properties of right triangles help builders construct ramps that meet this requirement. In addition, a police officer uses trigonometric ratios and other formulas to calculate the speed of a car as it was traveling in an accident. So many jobs out there that you may not realize do use trigonometric ratios. By the angle-angle similarity postulate, a right triangle with a given acute angle is similar to every other right triangle with the same acute angle. So if you look at this example, we know that all three of these triangles are similar because of angle-angle similarity. And we know that all of the sides are proportional. These are the trigonometric ratios. Every side that is written as a ratio to another side are trigonometric ratios. A trigonometric ratio is a ratio of two sides of a right triangle. Make note of this. This is only going to work in right triangles, just like Pythagorean theorem. So here they are, trigonometric ratios. Today we're going to learn about sine, cosine, and tangent. There are others, but we are just going to learn about these three. And there is one thing that you have to memorize, and that is this. Sine, cosine, and tangent each have a separate ratio in regards to a right triangle. You must know which two sides we are talking about in relation to the angle. So first off, I'm just going to go over the definitions of each of these. The sine of an angle is the ratio of the length of the leg opposite the angle to the length of the hypotenuse. So sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is the ratio of the length of the legs adjacent to the angle and to the length of the hypotenuse. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And lastly, the tangent of an angle is the ratio of the length of the leg opposite the angle to the length of the leg adjacent to the angle. So tangent is opposite over adjacent. Opposite over adjacent. You must memorize these three things. Now, here's the tricky part. Looking at a right triangle, the hypotenuse is the only thing that remains the same. The opposite and the adjacent legs could switch between either A or B, depending on which angle we're talking about. Now, I'm going to go one step further. Do you notice that the right angle is C? We are not using the right angle in any of our trigonometric ratios, and that will be true for everything, and here's why. If you, for example, took sine of C, sine of C is opposite side over hypotenuse. Well, the opposite side to angle C, it's color-coded here, is the same thing. So you'd actually have C divided by C, which is just 1. So when we talk about trigonometric ratios, we are only going to be using the two acute angles in a right triangle. So if we look at sine A is right here. Angle A is right here. The side opposite it is across. It's color-coded. So opposite over hypotenuse would be A divided by C. Sine of angle B, opposite over hypotenuse. That would be side B over the hypotenuse C. Cosine is adjacent over hypotenuse. So you'll notice the hypotenuse once again is still C. It remains the same. Cosine of angle A. Now let's look at this. Cosine of A, the opposite side is A, but we're not using the opposite side. The adjacent is the other leg, which is the side next to it. So B divided by C, adjacent divided by hypotenuse. Angle B would be A, this side, because B is opposite, A divided by C. Adjacent side divided by hypotenuse. And the tangent is opposite over adjacent. It's using the two legs. So opposite over adjacent, opposite over adjacent. So tangent of A would be A divided by B. Tangent of B, opposite divided by adjacent, would be B divided by A. Now looking at example 1, we're going to find the trigonometric ratios. We're going to write each trig ratio as a fraction and as a decimal rounded to the nearest hundredth. Now in this problem, I'm just going to look at this. We're going to write all three trig ratios, sine, cosine, and tangent, for each angle. So when we start this, let's start with angle R. Now you'll notice each time we are writing an equation. When we find the sine, cosine, or tangent, we're finding it of an angle measure. So in here, we're calling it R, we're finding R and S. Later on, you're going to start using things like this, where it'll be like theta, or a Greek symbol. So right now, though, we're just going to use the letters of the triangle. So sine. Sine is opposite over hypotenuse. So if we're looking at R, which is right here, what side is opposite angle R? It's 12. And the hypotenuse is 13. So this would be 12 thirteenths. Cosine of R would be adjacent over hypotenuse. So the adjacent side is 5 over the hypotenuse divided by the hypotenuse. So that'd be 5 thirteenths. And tangent of R is, well, tangent is opposite over adjacent. So opposite over adjacent. Opposite over adjacent would be 12 divided by 5. Now it says that we have to divide each of these to get a decimal rounded to the nearest hundredth. So sine of R equals 12 thirteenths would be approximately 92 hundredths. 5 divided by 13 is approximately 38 hundredths. And 12 fifths is 2 and 40 hundredths. So now let's do sine, cosine, and tangent of angle S. Sine of S is opposite over hypotenuse, so that would be 5 thirteenths. Cosine of S, adjacent over hypotenuse, that'd be 12 thirteenths. And tangent of S, that's opposite over adjacent, that'd be 5 twelfths. If we write those all as decimals, we would get these three values. In example 2, we're going to use a special right triangle to write sine of 60 as a fraction. You will notice that we have a special right triangle. You are going to be using special right triangles all the time in trigonometry. So sine of 60. So that'd be sine of 60 degrees. So now we look at this and go, okay, so we have sine of 60. Sine of 60 is right here. So if sine of 60, and remember sine is what? Sine is opposite over hypotenuse. So opposite over hypotenuse. Opposite over hypotenuse would give us the ratio s root 3 divided by 2s. So we'd have to simplify that. That would simplify into root 3 divided by 2, since the s's do cancel. So your answer would be sine of 60 degrees equals root 3 divided by 2. Now example 3, you do not need to write down, but I want you to make note of this is what it looks like in your calculator. In your calculator, you are going to be able to calculate using the trig ratios. Find each to the nearest hundredth. So if I wanted to, for A, find the cosine of 76 degrees, you would punch in cosine of 76 degrees, and you would get a decimal value of approximately 24 hundredths. Same thing with sine of 8 degrees and tangent of 82 degrees. But there is one thing that students will always make a mistake on, always, and we have to be careful on this. In your graphing calculator, it can be set to two different modes. degree, and radians. For now, we want to make sure your calculator is in degree mode. So if you actually plug this into your calculator and you don't get these values, then your calculator is in radians, which I will show you tomorrow how you get that. So how you can turn it back to degrees. But it's under the mode button of your graphing calculator. Something to make note of. The hypotenuse is always the longest side of a right triangle. You know that. So the denominator of sine or cosine ratio is always greater than the numerator. Therefore, the sine and cosine of an acute angle are always positive numbers less than 1. Since the tangent of an acute angle is the ratio of the lengths of the legs, it can have a value greater than 0. This is a good thing to note. Sine and cosines of acute angles are going to be positive numbers less than 1, and tangent of acute angles can have values greater than 0. In example 4, we're going to use trigonometric ratios to actually find the lengths. We are solving now using trig ratios. Here's what we know, and this is why we use it. We have a right triangle. If you were given the two legs, or any two sides, you would just use Pythagorean theorem. But trig ratios are now used when you're only giving one side of a right triangle and then an angle measure. So we want to find the length of AB. Now this is incredibly important because each of you can do something different and you could still get the same answer. Now when I'm looking at this, I see that I am given 41 degrees, I am given the side that's opposite it, and AB is what I need to find, which I'm going to let be x. In this problem, you have to analyze, what do I use? You can use sine, cosine, or tangent. Now, I wouldn't use sine, though, because sine is opposite over hypotenuse. I don't know the hypotenuse, so you wouldn't use sine. Cosine is adjacent over hypotenuse. Well, I don't have the hypotenuse, so you wouldn't use that. What two sides do I have from 41? I have the opposite side and adjacent. Well, opposite over adjacent is tangent, so you would use tangent here. Tangent of 41 degrees equals the opposite side, and that would be 6 1/10, divided by the adjacent side, which is x. Now, I need to solve for x. So to solve for x, you would first multiply both sides by x. You're just going to inverse operations here. You just now have a tangent of 41 degrees. So that would give me tangent of 41 degrees times x equals 6.1. So how do I get rid of a times tangent of 41? I divide both sides by tangent of 41 degrees. So x would equal 6.1 divided by tangent of 41 degrees. It is important that you do not take the tangent of 41 degrees, get an approximate value, and then divide. It will not be accurate. So x is, if you round it to the nearest hundredth, which is what it says, 7.02. So AB, the length of AB, would approximately be 7 2/2 inches. And make sure we make note of this. Do not round until the final step of your answer. Use the values of the trig ratios provided by your calculator. Here are two more examples. Find the length of MP. I'm going to put an X on MP. I'm going to look at the 20 degrees. And I'm going to look at this and say, okay, I want to do 20. I have opposite side over hypotenuse. Opposite over hypotenuse is sine. So sine of 20 degrees is going to give me the opposite side, which is x, divided by 8.7. I multiply both sides by 8.7. So 8.7 multiplied by sine of 20 degrees is going to give me the value of x. So if you actually figure that out, MP, the length of MP, would approximately be 2 98/100 centimeters. Now there's something to make note of here. If this angle is 20 degrees, what's this angle? It's 70. if you actually did this, let's say you did this. I put a 70 degrees here. So now I look at this and say, I want to find x. And I have from 70 degrees, the adjacent and the hypotenuse. And I use cosine. And you did cosine of 70 degrees equals adjacent, which is x, over the hypotenuse, which is 8.7. You multiply both sides by 8.7. And you took 8.7 times the cosine of 70 degrees. You're going to get the exact same answer. So there are multiple ways to do this. YZ. Well, I have 38 degrees. I want to find the hypotenuse. So from 38 degrees, I have the adjacent side and I have the hypotenuse. Adjacent over hypotenuse is cosine. So 38 degrees, the adjacent side is 12 and 6/10 divided by the hypotenuse, which is x. I now multiply both sides by x. And then I would divide by the cosine of 38 degrees. And so if you actually mathematically figure that out, that would give me x as a value of approximately 15 and 99 hundredths. So the length of YZ is approximately 15 and 99 hundredths centimeters. Our last example talks about a wheelchair ramp into a house. The contractor is building a wheelchair ramp for a doorway that is 1 2/10 feet above the ground. To meet ADA guidelines, the ramp will make an angle of 4 8/10 degrees with the ground. To the nearest hundredth of a foot, what is the horizontal distance covered by the ramp? Step 1, I'm going to redraw the picture. We know that it makes an angle with the ground of 4.8 degrees. The wheelchair ramp for a doorway is 1.2 feet above the ground, so this would be 1.2 feet. What is the horizontal distance? The horizontal distance would mean finding this side, length of CB. So what do I have? I have 4.8 degrees. I have the side opposite it and the adjacent side. So that means I'm going to use tangent. Tangent of 4.8 degrees equals the opposite side. Opposite over adjacent. So that would be tangent of 4.8 degrees equals 1.2 divided by x. I multiply both sides by x. I then divide by tangent of 4.8 degrees, and the length of BC would be approximately 14 and 29 hundredths feet. And that would be the horizontal distance covered by the ramp. Your vocabulary for this section would be sine, cosine, tangent, and trigonometric ratio.